Professor Blaine Brownell. Can you hear me?
Yes, can you hear me?
Yes, sir. Yeah.
Hello.
Hi. Yes, so I'll introduce you to all the participants and we can have the formal session. So Professor Blaine Brownell, he is the Director, School of Architecture at the University of North Carolina at Charlotte, US. He is an architect and a researcher of emergent materials and applications. A former Fulbright scholar to Japan, he has authored 8 books on advanced and sustainable materials for architecture. He was elevated to the American Institute of Architects College of Fellows in 2020. He has influenced a lot of architects' capacity to evaluate emerging materials and employ new material applications that are technologically, environmentally, and aesthetically innovative. He has contributed significant scholarship on emerging material technologies and trends to deepen our understanding of how new materials transform the functional capacity, design potential, and environmental performance of buildings. His 4-volume Transmaterial series, a book, catalogs materials that have the most significant potential to redefine our physical environment. The Royal Institute of British Architects nominated Transmaterial for an International Book Award in 2007, and the American Society of Landscape Architects selected Transmaterial next as one of the best books of 2017. So it's an honor and privilege to have you here, sir. I welcome you to SPA Bhopal and to the workshop. Thank you. Over to you.
Thank you. Thank you. Thank you so much. The honor is mine. I dream of being with you there in India. Although that's not the case. I'm of course speaking with you remotely, which is very convenient that we can all do this. We can connect remotely. One day I would love to visit your university. So if I may share my screen, I will start my presentation on visible green. And is that indeed visible?
Yes. Very much, yeah.
Thank you. So thank you for that very generous introduction. As is evident here, I've been very interested in, as we think about the circular economy and we think about material innovation, as has been discussed at this event, I've been very intrigued by the ways that materials can tell stories that are evident for not only for architects, but also other users. And this first slide captures a moment for me of recognition at an earlier part of my career. So this is a news article that is symbolic of a trend that we have all seen in architecture and the built environment that pertains to the way that sustainable materials have been incorporated into designs. And so this is one way that sustainable materials have been incorporated. The title, as you can see, of the news article is "A Green Home Can Still Be Traditional." And I will jump down to the highlighted sentence below by the developer. One of the most remarkable things about this house is it's so unremarkable. This is the type of trend that, as a young architect and still to this day, troubled me, because I thought, well, why would we not use green materials to tell a remarkable story? Lance Hosey, who is an architect and environmental consultant, has discussed 2 types of green, or a kind of dichotomy, thinking about the expression of green materials. Considerations such as embodied energy, material sources, chemical content, and so forth has become a more familiar agenda to describe what he calls invisible green. And we all work on this project, the invisible green, insofar as it requires a lot of the kind of quantification of sustainable design that might not be evident to users, but also it could include things that are simply hidden from view. Visible green, in contrast, form, shape, and image, can have an even greater impact on conservation and comfort. So Hosey talks about a kind of image problem in architecture that has made it difficult to make a case for the use of green materials in new ways. And I'm showing a kind of so-called Earthship home that is symbolic of some of the work that we saw in the United States after the 1970 OPEC oil embargo, when we had an oil shock and crisis, and oil became very expensive, and there was a kind of dramatic shift, especially among a kind of fringe of architects at that time, to build houses with tires and not necessarily kind of mainstream approach from the architectural establishment. So for what it's worth, there became a kind of image associated in the 1970s with sustainable architecture that wasn't as appealing to the mass public. And Hosey conducted an interesting experiment based on a 2010 Vanity Fair article. And the journal had asked 90 leading architects to pick the greatest buildings of the past 30 years. And Hosey, who was at the time writing for Architect magazine, conducted a similar poll for sustainable design, not just greatest buildings, but most sustainable buildings in the past 30 years. Not one building appeared in the top 20 of both lists, and not a single American architect appeared in both sets of winners. And this is the case that he was trying to make, is that we still have a lot of work to do to associate great buildings or great design with green design and the expression of what that can be. In my career, I've been fascinated with new materials. And when I say new, it's not necessarily completely novel, also rediscovered materials and products, even from kind of indigenous cultures that are being rediscovered or re-engineered or repurposed. Suffice it to say that in the last few decades, there has been a dramatic increase in the number of available new products and systems and assemblies for architecture, many of which have incredible environmental performance characteristics. And so a lot of the impetus for me of telling a green story has to do with the available offerings in the marketplace or in the laboratory in terms of what green materials can be and do and the stories that they can tell. So today I will talk about 5 approaches just to illustrate several different examples. These are quite varied in nature that represent ways that new materials or new material strategies can be used to tell a sustainable story. I'll start with this strategy of remediation, which is simply put, self-cleaning or cleaning up the local environment, purifying the local environment. So why do this? Why would it be green to remediate? 2 things, and for each of these topics, I'll address the kind of impetus or the why. The environmental degradation is one. So the increase in the amount of smog or air pollution in a lot of cities. If cities can play a role in mitigating that smog, then that would be a good thing. The other reason would be building maintenance. If there are materials, which there are, that can reduce that maintenance, then they would reduce not only human labor, but also additional resources required for that maintenance. So on the air pollution side and the smog side, it's been fascinating to see the number of new systems, many of which are plant assisted. They're essentially living systems, such as this active modular phytoremediation wall system, which uses internal fans in these modules to blow air across these exposed plant roots that oxygenate and purify the air for users. On the cleaning side, kind of self-maintenance side, a number of new materials and systems, such as this Lotus-On paint, have self-cleaning properties based on their nanostructure, the kind of surface nanostructure, which is in this case meant to mimic the structure of a lotus leaf, which can maintain, in the presence of rainwater that's required to pull dirt off the surface, that can again maintain cleanliness even in marshy, dirty conditions. And I think there are comments in the chat. I can't see that yet, but thank you for your comments. Keep putting them in, and I will, at the end of my talk, I'll look at those. Regulation is another topic, and Vivian Lofness, who's a professor at Carnegie Mellon, has used the term surfing nature to describe how we can do a better job of taking advantage of current properties, contextual properties or forces. This is pretty obvious, but solar angles, prevailing winds, and ventilate and condition buildings better just simply by being more contextually responsive. And materials and systems can help us with that as well. So why do that? Pretty obvious answers. One is to be more energy efficient. Another, when it comes to ventilation in particular, is to make buildings healthier. This is especially problematic in buildings that have fixed windows, windows that are not operable, and enclosed spaces that never breathe. And of course, with COVID, we know this is even more important to reduce the kind of aerosol transmission of a virus like COVID. So on the energy efficiency side of things, solar responsive envelopes of many kinds can play a significant role in helping to reduce solar heat gain in buildings. This is just one example of a smart material. This is an electroactive polymer based window shade system designed by Decker Yaden. And the configuration resembles kind of cellular structure or muscle fibers or something like that. But you can see the general response is indicated in the sample in the lower right there, where these blinds automatically open and close with very small amount of electrical input that can be, of course, tuned to solar angles. I should mention too, in each of these examples, I'm showing a kind of conventional representation at the lower left of the circumstance. And in this case, a kind of typical blind that's not smart that's used in the lower left. Similarly, with this smart ceiling system, I'm showing a kind of conventional dumb ceiling on the lower left, this Stratus project is a smart interior surface, and this is a ventilating ceiling. It does a number of things as a kind of integrated design as a system. This ceiling does have acoustic baffles. It does have integral lighting and ventilation. It has smart sensors that detect the presence of human occupants and where they are, what their temperature is, and provides illumination as needed, as well as ventilation as needed. And I think this is just a great illustration of what an integrated assembly can look like, as opposed to many of our assemblies in the built environment are composed of a number of different types of products and trades that don't really speak to one another, similar to a lot of conventional commercial ceilings, which have many different functions, but they're not well integrated like this ceiling. Another strategy is harvesting, similar to surfing nature's harvesting renewable sources of energy. This is a pretty obvious, it's pretty obvious why we should do this, because buildings consume so much energy, as well as to avoid problems with the energy grid. In the United States, our energy grid continues to age. It's very old and outdated and becoming more and more obsolete and insecure. And we do have blackouts not infrequently here, which is alarming, but luckily nothing too long in recent years, but still it's possible. So renewable energy can and should play a larger role in helping our grid be more reliable, and also distributing the responsibility or the capability of harnessing energy and sharing that capability with individual buildings. This isn't one example, so I'm trying to show some examples that might be slightly less conventional than what people have seen. This example of a wind harnessing facade in this case, it's a parking garage in Nagoya, Japan, by Inaba Electric Works, uses vertical axis wind turbines. And I appreciate that they're painted different colors and different surfaces so they accentuate the movement. It's like an art piece that constantly moves in the city. And this wind harnessing facade powers the lighting in the shopping mall next door. And again, I think this is a great marriage of art and science, and personally more aesthetically pleasing than a kind of typical parking garage as shown in the lower left. This is a whimsical kind of solar power called Grow that looks like a cartoon of ivy or leaves. It is. I mean, it's sort of like a cartoon or an illustration. What's the reason? There is a reason that these leaves are that they're three-dimensional in this case, is that in addition to the thin film photovoltaic incorporated harnessing solar energy, that piezoelectric components also harness wind energy, so that when the leaves flap, they harness wind energy as well. And this is compared to the kind of typical installation you see in the picture down below. Repurposing is a very important, as discussed in the last topic, thinking through circular economy strategies, a very important way to take advantage of first life materials and second lives. And we would do this for obvious reasons, that there's a lot of embodied energy and carbon in materials. And also a lot of buildings are demolished prematurely, and we need to take advantage of those materials. for new uses. And I've been very fascinated with strategies like this by Amateur Architecture Studio to reuse salvage building materials in new ways that were not at first expected, such as roof tiles and pavers and all kinds of other components into new building facades to tell a story, kind of palimpsest of past architecture. And to create new materials with, in this case, agricultural waste, using wheat board to create new kinds of tile that have embodied carbon and perform a lot better than kind of conventional ceramic tile environmentally. And in this strategy called support, we're looking at supporting habitat for not just for humans, but for other species. And why we would do this, of course, is to try to curtail the rapid biodiversity loss that we're seeing in the world that human development is causing, and also to remove obstructions, or at least to provide new supports for migrating species. I really appreciate this project by Loom Studio that re-envisioned conventional concrete masonry units to provide habitat opportunities for birds, nests, or different types of lichen and moss growth. This project by the Polytechnic University of Catalonia is similar to the last in that this biological concrete is developed with the intent to support growth for these plants, as well as the small insect and bird species that they would support. So those are just a number of, I find, kind of fascinating strategies to represent green ideas and green performance in architecture. So just a few thoughts to conclude with is that throughout the history of architecture and different traditions, there are monuments that represent our canon, many of which have technological or they have material innovations that are embodied in those monuments, whether it's the tallest wood structure in the world in Todaiji, or building tall with stone in the case of Gothic cathedrals, or skyscrapers. And of course, these are all about size, but in many different ways, right? Thinking of material innovations that these types of monuments we point to as a human society to say these are moments of human achievement. And so a question is, can we do this? And we should. We should do this in terms of environmental performance as a form of achievement. In other industries, there's a marketing component to this, right? I mean, this is just one way to market green design. Tesla markets its own version of green design, but people see Teslas or Prius or various types of automobiles or products that have a kind of conspicuous marketing dimension to saying, and whether they're truly green in every way or not, there is a kind of that marketing component, which is intriguing, and architecture hasn't quite had the same type of market power yet in terms of what that could look like. And when we look at natural systems, in terms of the embodiment of technology, let's say natural technologies and design, nature is what I call unapologetically radical. It's in terms of its form and its expression of its performance. It is quite beautiful, stunning, awe-inspiring, right? And architecture should be no less so in terms of environmental performance. And so a concluding question is really how else can or should green be made visible in architecture? As I've shown today, I don't believe that there's any one style or any one way that this can happen or should happen. It's really a question for architects and the larger design community to consider these different methods and how we should move forward. So I will stop sharing my screen.